Hello, my name is Asif Bahal and today I will be presenting my project titled GUI-based TCP port scanner, a Python project for scanning open TCP ports through a desktop GUI. This project was developed using Python 3 Tkinter socket programming and the unit test framework. The objective of this project is to design and implement a functional TCP port scanner with a graphical interface, demonstrating practical understanding of socket programming, input validation, modular design, and automated testing. Before discussing how the application works, it is important to first understand the fundamental concept behind it: network ports. In computer networking, a port is a logical communication input used by application to send and receive data. Each service runs on a specific port number. For example, 0 to 1023 range are also known as well-known ports and used by standard services. For example, 21 is known as File Transfer Protocol (FTP), 22 as SSH, and 1024 to 49151 are also known as register ports. These are mainly used by applications or services. For example, 1433 are used by Microsoft SQL Server, 1521 are used by Oracle DB, 49152 to 65535 are also known as dynamics or private ports. They are temporary client-side use. For example, 49,152 to 55,000. In the screen, there are common ports and what they do. Like these are the common ports my scanner identifies in common services in scanner.py file. For example, port 21 is also known as FTP, used to upload/download files between computers. Port 22, port 23, port 25 SMTP, port 53 DNS, port 80 STTP, port 110 POP3, port 143 IMAP, port 443 HTTPS. Now let us look at the tools and libraries used in this project. This project uses Python 3, Tkinter for GUI, Socket for TCP communication, unit tests for testing all my files. These tools also a specific role in separating logic, interface, and validation. The project structure follows a modular structure. Inside the program folder there are four files: scanner.py, geo.py, main.py, and text.py. This separation ensures clean architecture and maintainability. Now I will briefly explain the responsibility of each file. Scanner.py is a core logic file. This file contains scan port and scan range, common service dictionary. These modules handle all networking operations. Importantly, it does not depend on the GUI. This allows it to be used inside independently. View.py it user interface built in the window. The function create GUI creates the window, adds input fields as the start scan button. Displays result. The function start scan reads input, validates data, calls scan range, displays output. This ensures separation between logic and presentation. Main.py entry point. This file simply runs if name equals to main. It imports create GUI and launches the application. This keeps the execution clean and organized. The key functions are scan port, attempts or TCP connection using connect -ex. If the connection succeeds, the port is considered open. If it fails, it returns none. Scan range looks through a given port range. For each port, calls scan dashboard, stores open ports, map service names, return a list of open ports. Start scan function handles input validation, error dialogues, output formatting. These functions connect the GUI to the scanner logic. Testing file test.py. Testing is essential to verify reliability. This project includes three automated tests: test dash close dash port, verifies closed ports, return none; test scan range, return list, ensure scan range always returns a list; test invalid IP, confirm invalid IP address, do not crash the program. Running Python test.py, all tests pass successfully. Now I will demonstrate the working application. Now I will show you my project demo. First of all, I will scan my own machine. Second, I will use XAMPP to open ports. Third, I will use Docker virtualization containers. First of all, let us start with my own host machine. In my host machine, first of all, I need to have IP address of my computer. So you can pretty much find your IP address by typing ipconfig. You will get your IP address right in below in IPv4 address section. So you just basically need to copy it, Control C, and and run your program. Now you can pretty much find a graphical interface for it. So the IP address you copied, just paste it in here. As you pasted it, you need to put start port and input. So it just practically scanned the entire system and it found no open ports are found. So for my host machine, it is this much. Now let us go with second method using XAMPP. I'm using XAMPP because I want to test if my TCP scanner is working correctly or not. First of all, you need to have XAMPP installed in your system. But it is okay if you don't have it, because if you practically scan your own system and it shows port, then it is completely okay. So in XAMPP, you need to start. I'm going to start two things. One is Apache and another one is MySQL. Uh, after scanning, after scanning, I'm going to input target IP. I'm going to input target IP. So my target IP is 127.0.0.1 and its starting port is 1 to ending port is 1024. So when I start scan, it will take a very long time because I use sequential port scanning method rather than threading. So the timeout for each port is 0.3 seconds, so it will take a long time. Or you want to have the result faster, then put some smaller places. So while scanning the gem target IP, we found this ports open. Port 80 STDP, port 135 unknown service. It is unknown service because I haven't mapped them in my program. Port 443 is open, which is HTTPS, and port 445 is open, which is also unknown service because I haven't mapped them in my common dictionary. Sorry, I will not be adding the Docker virtual forward demo because due to some technical difficulties in my device. Now let us talk about future improvements. Although functional, this project can be improved by adding multi-threading for faster scanning, implement banner grabbing, exporting result into CSV, PDF, or TXT, stronger input validation, adding UDP scanning support. This investment will make the scanner more advanced and efficient. Conclusion. To conclude, this project successfully demonstrates the software programming, GUI development using Tkinter, modular architecture, automated unit testing, proper exception handling, and ethical reminder. Code scanning should only be performed on systems you own or have permission to test. Unauthorized scanning may violate cybersecurity laws. Thank you for your time.